Alright, hello everyone. So we're going to be talking about the average rate of change. So average rate of change measures how much a quantity changes relative to another over an interval, and it appears across a wide range of practical contexts and methods. So the average rate of change of a function over the interval from x equals a to x equals b is f of b minus f of a divided by b minus a. Okay, now this is the same, you might recognize it as the same thing as the gradient formula, delta y over delta x, or the change in y over the change in x, which is equal to rise over run. So finding the gradient in a lot of these questions will give us the average rates of change. Okay, so if we have 2 points, for example, this point and this point, and we're looking at the change in temperature, for example. So this might be temperature and this might be time. And you're trying to find the average rate of change between these 2 points. And if we had the 2 coordinates of these points, then we could just sub it into that formula above here. And then we can actually figure out the average rate of change by just finding the gradient between those 2 points. Okay. So some more practical context. The average rate of change formula applies whenever 2 related quantities are changing together. So common examples include average velocity as well. So change in displacement over change in time, average rate of temperature change, and average rate of population growth. So all of these things can be found using the gradient formula. For velocity equals the change in displacement over the change in time. So that's another practical way you can look at the average rates of change. All right, so to summarize, average rate of change is calculated as change in y over change in x, the gradient of the line between 2 points on a function. It applies in any context where one quantity changes relative to another. Always state the units of the rate and interpret the sign. So positive means that it's increasing, negative means that it's decreasing over the interval. All right.